To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, so I'm going to continue the lesson current electricity. In the previous chapter, we discussed the different types of resistors. So there are three types of resistors that we are going to discuss in this lesson. The fixed value resistors, variable resistors and light dependent resistors. So I discussed what fixed value resistors are. They have a fixed value. Say 5 ohms, 10 ohms, 1000 ohms, 12,000 ohms or 1.2 kilo ohms, like that. They have a fixed value. And usually, to calculate that fixed value or to know the resistance of a fixed value resistor, we use a color band. So normally there are 4 color bands marked in a resistor, and using that we will be able to calculate the resistance value. So that is what we are going to discuss now. Resistors with 4 color bands. In this method, 4 color bands are marked on the resistor as shown in figure. So if you look at the figure, you know this is the type of the resistor, then the 2 terminals, that is something you can see. Then look at the 3 bands. Don't read this now, just look at the 3 bands. You can see a blue color band, then red color bands. They are all close to each other. The first 3 bands are close to each other, and this last band, a brown color band, is a little away from those 3 bands. So what you need to do is you need to place this resistor in such a way that the bands that are close to each other have to be on the left hand side. Now if you look at the board, on your left hand side, the 3 bands that are close to each other are there. And on the right hand side, a band is there that is slightly far away from the other 3 bands. That is how you read the color band. Then, if you take the 4 bands, the first band is for the tens place. So, if it is a certain value, you write that value. Now here, I'll show you all the values. It is given in a table. With the values, we will learn to find the resistance of the resistor. So, it is the tens place. Then it is the ones place, the second band. So, you just write down the corresponding values directly. If the color corresponds to 1, you write 1. If the color corresponds to 2, you write 2. Color corresponds to 4, you write 4. Like that, you directly write the digits for the first 2 bands. Then we have the third band, index of the 10th power. If that color corresponds to, let's say, value 1, then you need to put 1, 0. If it corresponds to value 4, you need to write 4 zeros. And if the color corresponds to value 0, then there are no zeros. Similarly, if the value corresponds to 10 to the minus 1 or minus 2 index, so this is the index of the 10th power, then the value of the resistor becomes a decimal value. Then the fourth one is the tolerance level or tolerance interval, tolerance range. Now let's say, for example, if you have calculated 100 ohms as the resistance here, and if the tolerance range is 2%. So accordingly, you calculate 2% of the 100 ohms, and there will be a range, 100 ohm plus and minus the tolerance interval. So that is how we calculate. This is just the explanation to you all, an introduction only. I will introduce the colors, the values, and then I will show you all how to do the calculation. So we'll move on to the next slide. The value assigned to each color is given in table, that's on the next slide. So if we go to the next slide, here you can see this is given in your textbook, resistor color codes. Here the numbers are given, the color. So black, the colors are indicated here, brown, red, orange. This should be yellow, students. It has to be yellow, not yellow, yellow. It should not be a T. It is a printing mistake in the textbook, so it should be yellow. Then here, yellow color, green, blue, purple, gray also should be gray. So, in some of your edition, students, these spelling errors would have been corrected, but if you have the older prints, you might need to correct the colors. So, then we have white, gold and silver. So, now let's say if the first band is blue in color, then what you do is you need to find the number corresponding to blue. So, here you can see 6. So, you need to write the value 6. Then if the second band let's say is brown. The value for brown, the number for brown is 1. Then you write the second digit as 1. So, we have 6, then you have 1, and then if the third color is red, the value of red is 2. So, I told you all, third one is the index of 10th power. So, there if it is 2, that means 10 to the power of 2. So, here you can see 10 to the power of 2. That is what is shown here. Number to be multiplied by according the color of the third and fourth bands. So, here third band, if it is red, it's 10 to the power of 2. So, you need to add 2 zeros. That will be your value. Blue is 6, brown is 1, then 2 0. So, the value of the resistor will become 6100, 6100. That is how we calculate. As I said again, now I am explaining. If you don't get it very clearly now, when I write and show you all how to do the calculation, you will understand more clearly. So, that is how we find the values. Then, like I said, if the colors are gold and silver, now here you can see 10 to the minus 1, 0.1. So, the resistance will be a decimal value. If it is silver, 0.01, 10 to the minus 2. So, that is also a decimal value. So, this is how we have the values. Black, brown, red, orange, yellow, green, blue, purple, grey, white, gold, silver. Accordingly, you have the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, minus 1 and minus 2. So, if it is the first two bands, you directly use the number. If it is the third band, accordingly you put the number of zeros. Third and fourth bands. Then we have the second table where we have color codes to resistor tolerance. That is the fourth color band. That is slightly away from the first three color bands. Here you can see color tolerance value. So, color, if it is brown, tolerance value is plus or minus 1%. If the color is red, plus or minus 2%. If the color is gold, plus or minus 5%. If the color is silver, plus or minus 10%. And no fourth color band means plus or minus 20%. So, is it clear to you all? You look at the first two color bands. Accordingly, you take the number. Then third color band, 10 to the power of 0 means 1, 10 to the power of 1, 10, 10 to the power of 200, this number and the power index are the same. So, then accordingly you put the number of zeros. Then here you have decimal values. And the second table gives you the color codes to resistor tolerance. Is that clear to you all now? The two tables given in your textbook. You need to know these colors and you need to understand what they are. Then, if I go back to the previous slide, so we started the slide So the value assigned to each color is given in table. We looked at the tables. In order to find the coded value of resistor, the number given by the first two color bands should be multiplied by a power of 10. The power which 10 should be raised to, index of the 10th power, is given by the value of the third band. Then the index of this value is given in column 1 of table. In addition to this, the indices corresponding to gold and silver are -1 and -2 respectively. I will read first and explain it to you. That is, in order to represent the resistor values for decimal valued resistances, gold and silver bands are used. The fourth band, marked apart from the other three, indicates the range that the resistor value can vary. Tolerance interval. Table shows the values assigned to the tolerance color codes. So for example, if we have a resistor, let's say there is a resistor with 4 color bands. Now this is not to indicate the color. Now we will assume the colors to be blue, red, red, and then we will say gold. 4 colors. So first 3 colors. Now we will have to look at the table also. Now for blue, blue is the first slide. Now here you can find the value. Blue is here. The number that corresponds to blue is 6. Then we have 2 reds. So what is the number corresponding to red? Is 2. So I'll go back to the previous slide. For blue, the value is 6. For red, the value is 2. So first 2, you have to write the digits. Now here you can see, in order to find the coded value of resistors, the number given by the first 2 color bands should be multiplied by a power of 10. So first 2 color bands is the number. Blue 6, red 2, so the value is 62. Then what do we do? The power which 10 should be raised to index of the 10th power is given by the value of the third band. So again, third band is also red. I told you all the number and the power index are the same. We will check it again. Here you can see number 2. Here 10 to the power of 2. 10 to the power of 2 means 100. 2 zeros. So what you do is you add 2 zeros here. So the value of the resistor, is equal to 6200 ohms. 6, 2 and 2 zeros. So the first 2 values, you directly write the number. Third value, it is the 10 to the power of index of the 10 to the power. So since that is also red, it has to be 2. So because of that, you need to have 2 zeros there. So the value of the resistor becomes 6200. Then we have the fourth line, the tolerance interval. We will find the value. For the tolerance interval, you need to use the second table. Second table is 5%, plus or minus 5%. So you need to calculate the tolerance range. You need to calculate the tolerance range. This is plus or minus 5%. So how do we calculate the tolerance value? Tolerance value. Now you have the value of the resistor. Tolerance value says 5%. What is the meaning of 5%? If the resistance is 100, tolerance value is 5. So if it was 100, it would have been 5. But since it is 6200, we need to find the value. So here we can simplify 100 and 0. So we have 5 into 62. That is going to be 0, 31. 5 into 2, 10, 0. Then 30 plus 1, 31 ohms. That is also going to be in ohms. So that is the tolerance value. We have calculated the value of the resistor 6200. This is 310 ohms. Now it says plus or minus 5%. So it should become plus or minus 310 ohms. So what do you do? To find the tolerance range, we have the value of the resistor 6200 ohms plus or minus 310 ohms. So you will have to have 6200 minus 310 ohms to 6200 plus 310 ohms. Why plus or minus? So plus and minus, when you subtract, you get the lowest value, the lowest tolerance range, and then plus you get the highest tolerance range. So from this value to that value. So here we need to find this value 6200 minus 310. So that is going to be 0. Then here it is going to be 9. Then 11, it's 8 and 5. 5890, it has to be ohms. That is the lowest value of the tolerance range. From that to the highest value, 6200 plus 310. That is going to be 6510 ohms. So now we have two values, the lowest and the highest value. 5890 ohms to 6510 ohms. That is the range. So if you have this resistor, what I showed you all here. Now here see the color codes are like this. Blue, red, red, gold. So in this you find the values of the first two colors, write the number directly. Then for the third color, you write the zeros. Because it is red, it corresponds to 2, 10 to the power of 2, that is 100. So you write 2 zeros, like this, 2 zeros. So you get the value of the resistor from the first three colors, 6200 ohms. Then the fourth color is for the tolerance, 5%. So what did we do? We calculated the tolerance value. 5% means for 100, it is 5. Therefore, for 6200, when you calculate, you get the value as 310 ohms. There you can see it shows as plus and minus 5% or plus or minus 5%. So, plus or minus 310 ohms. With that, we calculate the tolerance range. So 6200 ohms plus or minus 310 ohms. To get the lowest value, you need to subtract. So 6200 minus 310 ohms, you get 5890 ohms. From that to this highest value, 6200 plus 310 ohms. So you get the value as 6510 ohms. And that is the range of the resistor. So if you take a resistor where the color bands are blue, red, red, gold, the resistance has to be 6200, but it can slightly vary between these two values. So it can go down to 5890 or it can go up to 6510. That is how the tolerance works. I'm sure you all can understand this calculation now. But again, I will do another calculation, an example given in your textbook in the next slide. So here we already discussed this table. We will be using the table again for the calculation. So here, example 1. The figure below shows a permanent resistor purchased from the market. Now, if you look at the permanent resistor, you can see the colors. What are the colors? What is this first color? You can see it is brown. Then the second color, black. And then the third color, red. And the fourth color is marked as silver. So first 3 bands which are close to each other, and silver is the next one. So what do we need to do? We need to find the values from the table. And then you need to find the resistance. First one is find its resistance value. So resistance value, brown, black and red. So let's go back. Here you can see brown. Look at the value. It is 1. Then black is what? 0. So first 2 digits you write the number directly. Then for red you can see 2. Black, brown, red. So there, if we write the values, brown is 1. Black, what was the value? 0. And red, it's 2. 2 means 10 to the power of 2, that is 100. 100 again has 2 zeros. So what do? We put 2 zeros there. 2 zeros there. Brown is 1, black is 0, red is 2. So 1, 0 and 2 zeros. That is the resistance value of the resistor. Is that clear to you all? So if you are not sure, what you can do is, you can write the values. Now brown equals 1, black equals 0 and red equals 2. But for 2 zeros. So then you can write it. Brown 1, black 0, you put the 0. Red 2 for 2 zeros. So you put the 2 zeros there. Is that clear? So we have found the resistance value. You have to write the unit ohms. Then, second question, what is the tolerance value of this resistor? So what is the color there? Silver. What is the tolerance value? Now for that we need to use this table. Now brown, red, gold, silver. Silver 10%. So we have to use 10%. So what is the tolerance value of this resistor? To do that, we have silver 10%. So then what do? We need to calculate the tolerance value. For 100, it is 10%. Therefore, we have 1000 here. For 1000. So it's easy, no? You can simplify this and you will get the value as 100 ohms. You need to simplify the values. So 100 ohms. 10 into 1000, 10,000 divided by 100, 100 ohms. That is the tolerance value. Is that clear? Then the third one. What is the true range of values that this resistor could have? True range of value that this resistor could have. So how do we find that? True range of values. That is going to be 1000 ohms plus and minus or plus or minus 100 ohm. So to find the lowest range, what do? 1000 ohms minus 100 ohm to 1000 ohms plus 100 ohm. Always we have the minus first, subtraction first, then addition. So then you will get the lowest value and the highest value. So you will get 1000 minus 100, 900 ohms, 2000 plus 100, 1100 ohms. So the range is going to be 900 ohms to 1100 ohms. Is that clear to you all, students? Can you all understand this clearly? Now if we go back and check, we have the colors of the bands: brown, black, red, then silver. Then from the table, you find the values. Again, if you go back to the table and look at it, brown corresponds to number 1. Black corresponds to number 0. Then red corresponds to 2. So if we come back, brown is 1, black 0, red 2. To write the resistance or find the value of resistance, you directly write the first digit, brown 1, black 0. But for the third color, since the value is 2, that means 10 to the power of 2, so 2 zeros. So that is why we have put 2 zeros here. So the value of the resistance is 1000 ohms. Then to calculate the tolerance value, silver color 10%. So then tolerance value for 100 ohms, it's 10 ohms. For 100, it's 10%. Therefore, for 1000 ohms. For 1000 ohms. So you get the value as 100 ohm. That is the tolerance value of the resistor. Then you find the true range of values that this resistor could have, from the lowest value to the highest value. True range of values 1000 ohm plus or minus 100. So it will be 1000 ohm minus 100 ohm to 1000 ohm plus 100 ohm. That's how you find the range, no? Lowest to highest. So you will get the values as 900 ohms to 1100 ohms. Is that clear, student? I am sure you all can understand this. Finding the resistance of a resistor using the color band. And this one, 4 color band system. So with that, I will move on to the next slide. Again, we have an exercise. There also we will calculate the resistance of a resistor. So then there is this exercise 19.3 from your textbook. A resistor marked with orange, yellow and gold colored bands is provided to you. Find the value of the resistor. Second one, what is the tolerance? And the third one, find the range of values that the resistor could have. So what are the colors? Orange, then orange, yellow and gold. So you need to find the values. You can remember, students, black, brown, and then we start from red. So if I go back to the table, you can see black, brown, red, orange, yellow, green, blue, purple, then grey, white, gold and silver. Those are the colors. So orange, 3. Orange is 3. If we go to the question, orange, yellow. Yellow is 4. Orange is 3, 3, 4. Then for gold, we need to find the value for gold. Here if you want, you can see yellow is 4 and gold is 5%. So gold is 5%. So these are the color codes, students: orange, yellow and gold. So using that, we can calculate the resistor. So first one, find the value of the resistor. So how do you find the value of resistor? Value of resistor. First two values, you write the number directly. 3, 3. Then the third digit is the 10 to the power index. So it's 10 to the power of 4. So you need to put 4 zeros. So 3, 3 and 4 zeros. Ohm. So 330,000 ohms. 330,000 ohms, or you can say 330 kilo ohms. 330,000 is 330 kilo ohms. But to calculate the tolerance range and all, we need to have it in the ohm value itself, not the kilo ohms. So for the second question, second one, tolerance. Tolerance is what? Gold, 5%. So for 100, it's 5. Therefore, for 330,000 ohms. So that is going to be, if you simplify, 0, 0, 3 into 5, 15, 1, 3 into 5, 15 and 16. So that is going to be 16,500 ohms. That is the tolerance of the resistor. Then find the range of values that the resistor could have. That is the third one. Range of values. How do we find that? 330,000 plus or minus 16,500 ohms. So that is going to be 330,000 minus 16,500 ohms to 330,000 plus 16,500 ohms. So here, 330,000 minus 16,500. So if we subtract the values, 0, 0, then from 5, it has to be 5, then from 9, it's 3, then from 2, minus 1, so 313,500 ohms to 330,000 plus 16,500. So that would be 346,500 ohms. So 313,500 ohms to 346,500 ohms. That is the value, the lowest value and the highest value. Range of values the resistor can have. I am sure, students, you all also calculated this correctly. Let me go back and check the values, check the answers again. So for the resistors, I drew the line to show the colors of the band: orange, yellow, gold, then 3, 3, 4 and 5%. So value of the resistor, 3, 3 and 4 zeros, 330,000 ohms or 330 kilo ohms. Then tolerance, 5%. 5 over 100 into 330,000 ohms, 16,500 ohms. So to find the range of values, 330,000 plus or minus 16,500. So 330,000 minus 16,500 to 330,000 plus 16,500. So you get the values as 313,500 ohms to 346,500. So I am sure you all got the correct value, student. With that, I will move on to the next slide. Now we come on to the second type of resistor, variable resistor. Resistors fabricated so as to allow a variation in the resistance as desired are known as variable resistors. So while the resistor is connected to the circuit, you can adjust the resistance of the resistor. Or else you can adjust the resistance and connect it to the circuit. If you want, you can remove it, again adjust the value and reconnect it. So using one resistor, you can have different values. So those are the variable resistors. So here the resistor value can be varied manually or turning using a screw in an appropriate direction. So there by mistake there is a word, additional word in your textbook also, in an appropriate direction. So you can either turn it manually. Now you all know those televisions, radios, where you turn a knob and you increase the volume, decrease the volume. So you rotate it manually. Or you can use a screwdriver and rotate the screw and change the value of the resistor. So that is turning using a screw in an appropriate direction. There are many types of variable resistors such as pre-adjustment resistors, rheostats and volume control resistors. So those are the types. Pre-adjustment resistors, rheostats and volume control resistors. Now pre-adjustment resistors, like I said, you have the resistor, you adjust it to a certain value, then you connect it to the circuit. If you want a different value, you remove the resistor, you adjust it again and you can fix it back. Pre-adjustment. So before connecting it to the circuit, you have to adjust the value of the resistor. Then rheostat, what we used in the activity, the instrument where you change the resistor, rheostat. And volume control resistors like the volume control knobs. So three types. Figure A shows several variable resistors and figure B shows symbols used for variable resistors. So I have given figure A in the next slide and I will write and show you all the symbols for the variable resistor. So we'll move on to the next slide. So here you can look at all the three types. Now this is rheostat. You have seen that before also in the activity. So rheostat. Then pre-adjustment resistor. Now here can you see the value is 103. By turning the screw you can adjust that value. So according to your need you can change the resistance. Pre-adjustment resistor. Then volume controller. Now this part will be connected to the device. You can rotate the volume control and using that you can change the value while it is connected to the circuit. So volume controller, rotatable variable resistor. So while it is connected, you can change the value of the resistance. Same goes for rheostat. But volume controller is very much easy to handle. Rheostat also you can adjust it while it is connected to the circuit. But pre-adjustment you have to adjust the resistance before connecting to the circuit. So those are the three types, various types of variable resistors. Then we have the symbols used for variable resistors. Symbols used for variable resistors. So there we can have the symbols. So you can remember for the rheostat also we used a symbol. Now resistor, normal resistor fixed value, you only have the rectangle with the two terminals. But when you put an arrow across it in a diagonal manner, that resembles the variable resistor. Then there is another circuit symbol, no? Where you have the zigzag lines like that. Here. Here also you put an arrow across the symbol. So without the arrow, it is a fixed value resistor. With the arrow, it is a variable resistor. That is how you can easily differentiate them. These are variable resistors. You can use either of the symbols, this symbol or the second symbol. Okay, students. So these are examples of variable resistors, the rheostat, pre-adjustment resistor and the volume controller. And these are the symbols that you can use in the circuit. Now we will go to the lab and have a look at some of these variable resistors. Okay, students. So now we will look at some examples of variable resistors. So as you already know, variable resistors are connected to the circuit and we can adjust the value of resistance. Either we can adjust the value and then connect it to the circuit. If you want to change the value again, you have to remove the resistor, change the value and connect it back. Or while doing the activity, while the resistor is connected to the circuit, we can adjust the value of resistance. Both types come under variable resistors. As examples, we can look at 3 types of resistors. I have 2 of them here. The first one, rheostat. We have already used this in a circuit, in an activity, so you are familiar with this. The rheostat is a variable resistor. Now in the rheostat, you all can see, students, this is the nichrome wire coil. And nichrome is a material that has very high resistance. Now there are 3 terminals shown here. If we connect this terminal and this terminal, then when this knob is on this side, it is touching only a very few coils. So that means the resistance is less. But if I move this part somewhere here, now you can see these coils come as the resistor. So the number of coils increases. So we connect the 2 terminals here and here. So the connection is with this, and this metal rod is connected to this knob here. So this part is the resistor. So when the number of coils increases, the resistance increases. We can further bring it to this side. Again, you can see the number of coils increases further, resistance will increase further. If we bring it to this maximum position, the full resistor is in effect. The full length of the resistor is in effect. Full length of the rheostat. So that will give maximum resistance. So here you all have to remember, students, by increasing the resistance, we will be decreasing the current flow through the circuit. Now the same way, if you want to use these 2 terminals, then what will happen is, if we move this knob here and connect these 2 parts, the resistance will be from this part of the coil. So when you keep on moving it to this side, the length of the nichrome coil will increase, so the resistance will increase. That is if you use these 2 terminals. Normally, we go for these 2 terminals, but if it is needed in a particular circuit, you can use these 2 terminals as well. What if you connect these 2 terminals? Then, of course, you will have the maximum resistance. Why? All the coils are coming between these 2 terminals. So then also it will be the maximum resistance. If we want to adjust the resistance, we have to use these 2 terminals or these 2 terminals and adjust this knob so that the resistance changes. So that is how a rheostat functions. It is an example of a variable resistor. Then we have the next one, a volume control knob. Now here you can see, if you look closely from this side, you can see there are pins. Those are connected to the circuit board, and this part is there, and this is the knob that we can rotate. Now here I can rotate this knob. So that is like a volume control knob. So by rotating the knob, you can change the resistance. So this is a volume control resistor or volume controller switch or volume controller that can be rotated, and thereby the resistance can be varied. So that is also an example of a variable resistor. Then you are familiar with pre-adjustment resistors. So like I said, these two resistors, you can change the resistance while they are connected to the circuit. But pre-adjustment resistors, you have to set the value of the resistor and fix it to the circuit. If you want to change the value, you have to remove the resistor, change the value again, and then connect it to the circuit. So all these three are variable resistors. Okay, students. So you were able to see the rheostat and the volume controller. I did not have a pre-adjustment resistor. We have already used the rheostat when we tried to verify the Ohm's law in the activity. So you know the function also, and you have understood how it works, and the volume controller. So I'm sure you all can understand what variable resistors are and what their functions are. With that, students, I will move on to the next slide. So here you can see the uses of variable resistors. Variable resistors are used to control the volume of radios. So here, control the volume of radios to adjust electronic circuits, and to vary currents in laboratory experiments. So these are the uses. Volume control, like I said, when you have a radio, now sometimes you have those digital buttons where you press volume increase and volume decrease. Even in smart boards, laptops, you usually use the buttons. But in radios, you have that knob where you increase and decrease. So that is the controlling knob of the volume control. So control the volume of radios. That is using a variable resistor. Then to adjust electronic circuits. We will be discussing electronics in grade 11. So there you will see when there are circuits mainly with transistors or diodes mainly with transistors, when we have the different functions of transistors. There we will be using these variable resistors to change the resistance of the circuit. So that is another function. Then we can vary currents in laboratory experiments. We did the activity to find the relationship between current and potential difference to come to the point where we discussed the Ohm's law. So there we used a rheostat. So those are some of the uses of variable resistors. That is volume control, pre-adjustment resistors, and rheostats. They can be used for different purposes. With that, students, I'm going to move on to the next slide where we discuss the light-dependent resistors. So we are discussing the types of resistors, 3 types: fixed value resistors, then variable resistors, and finally the last type, light-dependent resistors. Light-dependent resistors. Light-dependent resistors are abbreviated as LDR. LDR, light-dependent resistors. Light-dependent resistors, LDR, are fabricated using chemicals such as cadmium sulfide. Cadmium sulfide is a chemical compound. Value of the resistance depends on the intensity of light. That is why we call it light-dependent resistor. Intensity of light. When there is no light, the resistance is high. That is in the dark, during night time, if there is no light falling, or if you cover the resistance with your hand or with a cloth, there is no light falling on the resistor, then the resistance is high. When light falls on it, the resistance decreases. As the intensity of light increases, the resistance decreases further. So if there is very bright light, there will be very less resistance. That is the light-dependent resistor. So here you can see In the dark, when the light intensity is low, the resistors have a high resistance. So light intensity is low, they have high resistance. In the presence of light, their resistance decreases. So light-dependent resistors are used in control circuits of instruments that need to operate based on the amount of light falling on them. So maybe alarms. When there is light, current has to flow through it and the alarm has to go off. A fire alarm probably. When there is fire, there is lot of light. So because of that, the resistance of the light-dependent resistor will decrease. That will allow the current to flow through the circuit and the alarm will go off. When there is no light, then there is no current flow because the resistance is high. Something like that. So you can imagine instances, think of instances where these light-dependent resistors can be used. When there is no light or intensity of light is very low, resistance is high. Here you can see high resistance when the light intensity is low. But as light falls, the resistance decreases. Is that clear to you? So here, these first two diagrams are the circuit symbols of light-dependent resistor. Now the symbol for resistor, you need to have a circle around it and you need to show the arrows to indicate that it depends on light. Light falls on it. The arrows to indicate the light falling on it. The second symbol, the zigzag lines, again surrounded by a circle and the light falling onto it. So that is how we represent light-dependent resistors. And here, this is the real light-dependent resistor. Here you can see the two terminals and the surface. That is where the resistance changes. And that is made up of cadmium sulfide. Is that clear to you all? A, symbols used for light-dependent resistors, and B, the appearance of a light-dependent resistor. So this is what you need to know about light-dependent resistors. Okay, students. So now that you know the circuit symbols of light-dependent resistors, I will go to the lab and show you a light-dependent resistor. So we have been discussing about different types of resistors, and under that the third type, that is the light-dependent resistor or the LDR. So here I have two LDR. If you look at the LDR here, can you see the surface? So that part is sensitive to light. When light does not fall on that surface, say if now there is light falling, if I cover it with my finger or if you cover it with a cloth, then there will be no light falling on the surface, or in the night time when there is no light, then the resistance of LDR will be very, very high. If that is connected to the circuit and no light is falling, the resistance will be high. There will be very less amount of current flow or no current flow at all. But when light falls on this surface of the LDR, the resistance decreases. And when resistance decreases, there will be current flowing through the circuit. So this is used in instances where we need to change the resistance depending on the intensity of light. And that is why it is a light sensitive resistor or light dependent resistor, LDR. So you have seen an LDR, I'm sure you will understand the function. This is also another LDR. And like I showed you all before, even the LDR has two terminals. Using these two terminals, we will be connecting the LDR to the circuit. Okay, students. So then you have seen the light-dependent resistors. You saw how the terminals were and this particular surface. And to emphasize the function again, when the light intensity is less, the resistance is high. When light falls on the resistor, the resistance decreases. So as the light intensity falling on the resistor increases, the resistance decreases. That is the function of a light dependent resistor or LDR. I'm sure you all can understand that clearly. So in this chapter, students, we started off the chapter by discussing how we can calculate the resistance, the tolerance value and the range of the value of resistor when there is a color code used in fixed value resistors. Then we discussed the different types of variable resistors and now the light dependent resistor. With that, students, I am going to end this chapter, and in the next chapter I will discuss how we can combine resistors and then how we can find the equivalence resistance of the combined resistors.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.